That's a good question. Actually, we didn't start it with cleaning. We started actually doing snow cleaning. So we are in Canada, as you can imagine, and me and my co-founder, we were in Ottawa at the time. So over there's a lot of snow. It snows about 20, 30 days a year, very badly, like very many centimeters. So we were looking at that first. It was a really exciting engineering problem, very difficult to clean snow at that time. But as we were doing customer discovery and understanding the business, in fact, it was one of the snow cleaning operators who told us, "Hey, I only have like 20 of this a year, but in the grocery store over there, they do it every night." Yeah, so yeah, cleaning. I guess even when I describe how we used to think, it sounds simpler than snow cleaning for sure, and maybe it does sound simple, but it is actually quite tricky, quite complicated. If you really start thinking about, okay, a whole airport, how will I go about cleaning the whole airport? Perhaps one of the most interesting challenges is coverage planning. Is basically a topic of planning research. And it is, basically, and as oftentimes happens in robotics, there is a problem, and certainly in the academia is semi-solved, but it's not completely solved, right? There's that extra step. And so if I was to give you a map of the facility or of a grocery store, for example, really complicated, has all these like 5-foot aisles, 6-foot aisles, it changes all the time. So I think certainly coverage planning is semi-solved in the academia, but then when you try and apply it, you see that all the failure points and all the things, it's really not quite a solved problem. So coverage planning is one of those very, very tricky problems. How do we optimize, how do we make sure the robot is always cleaning with the most optimal way, even though the environment has changed constantly? It's certainly challenging.
In this podcast, I'm sharing my passion and curiosity for soft robotics, where we share inspiring stories about the work we do and how we can push the limit. I am Mara Dwini, and this is Soft Robotics Podcast. Support for this show comes from Science Robotics Journal. I really find Science Robotics to be a great resource for reliable and tangible research where we can really push the limit of the science we do in robotics. Great way to stay up to date with the published article is checking out the released monthly issue. All the links will be included in each episode description. We will also happen to have a regular conversation on the most published science robotic articles, where also you can contribute with your question and thoughts about the research. Thanks Science Robotics for sponsoring Soft Robotics Podcast. So maybe I would like to ask you first how you'd like to define who you are for people maybe first time listening to you. How would you like to define yourself?
My name is Pablo. I'm the CTO, VP of Product and Chairman of Avidbots. I've been working in robotics from the very beginning, from the very first years of university. I've been, in this goal to bring robots to the real world, and really happy to be doing that basically at Avidbots day to day.
Great. So maybe if we can tell the beginning, what is Avidbot? I think it's familiar. We can see it in DHL, and it's doing a really great job here. It's familiar. But if you can just tell us what Avidbot actually about, for people just to understand. Yeah.
Absolutely. Our vision is to bring robots to everyday life to expand humanity's potential. We have a hyper focus on cleaning. So we make Neo the world's best self-driving floor scrubber. So it's basically like a Roomba, but bigger. It's basically for larger spaces like an airport, like a retail store, that kind of place. So a robot cleans for about like 5 hours on a battery charge. So it essentially cleans all by itself the entire facility.
Great. So we want to ask you, Pablo, here at the beginning, starting with the cleaning robot. You focus on this problem, and you mentioned there's Romba here. So when you started the company with your partner here, how you choose a problem, since there's already something Romba but smaller scale. So get us about the thoughts of the problem and how you started, how you managed to know that's exactly what the market need, which you already have a
customer detail and airport, etc. But at the beginning, how it worked in your mind and with others to focus on cleaning problem here for other robots here?
Yeah, no, that's a good question. Actually, we didn't start it with cleaning. We started actually doing snow cleaning. So we are in Canada, as you can imagine, and me and my co-founder, we were in Ottawa at the time. So over there, there's a lot of snow. It snows about 20, 30 days a year, very badly, like very many centimeters. So we were looking at that first. It was a really exciting engineering problem, very difficult to clean snow at that time. But as we were doing customer discovery and understanding the business, in fact, it was one of the snow cleaning operators who told us, "Hey, I only have like 20 of this a year, but in the grocery store over there, they do it every night, and they do it for many hours as well." So that's, I think, when it really it dawned on us the importance of this ROI and the importance of this return of investment and number of hours that you need to automate per week. I think that's a very powerful, data point that is basically with us until today. So yeah, that's how we started looking. Then yeah, we started paying a lot of attention to cleaning robots, like industrial cleaning robots, and it was quite eye-opening. I think the industry already had like a few players, but they were using technology from like the 90s, like sonars and stuff like that. So we didn't see anybody using the modern like probabilistic robotics approaches that we have. So it was certainly an opportunity for us to bring those innovations into the market, and yeah, then here we are, definitely still growing strong. So it's certainly a problem that can be solved with the current technology for sure.
Mm-hmm. Maybe I want to focus again about the problem. You mentioned this point, I think it's interesting. But if you can tell us about the problem that Avidbot solving in cleaning robot and maybe not touch it in other players here without mentioning other names, but if you can tell us about Avidbot, that's a problem and that's what you make you stand out in this problem. If you can tell us about what exactly is, yeah.
Yeah, absolutely. Cleaning. I guess even when I describe how we used to think, it sounds simpler than snow cleaning for sure, and maybe it does sound simple, but it is actually quite tricky, quite complicated. If you really start thinking about, okay, a whole airport, how will I go about cleaning the whole airport? Perhaps one of the most interesting challenges is coverage planning. Is basically a topic of planning research. And it is, basically, and as oftentimes happens in robotics, there is a problem, and certainly in the academia is semi-solved, but it's not completely solved, right? There's that extra step. And so if I was to give you a map of the facility of a grocery store, for example, really complicated, has all these like 5-foot aisles, 6-foot aisles, it changes all the time. So I think certainly coverage planning is semi-solved in the academia, but then when you try and apply it, you see that all the failure points and all the things, it's really not quite a solved problem. So coverage planning is one of those very, very tricky problems. How do we optimize, how do we make sure the robot is always cleaning with the most optimal way, even though the environment has changed constantly? It's certainly challenging. The other piece, of course, is certainly around localization. So we have a robot able to localize in a facility. But again, what if, imagine in a grocery store where they have seasonal changes. So they basically changed everything, and now there's grass cutting machines, and tomorrow is Halloween or something. So it's very different. And so how do you localize? How do you know that you're still in that location, even though the map has changed drastically? It's one of those problems that there's basic solutions in academia, but once you try and apply them to the real world is a lot tougher, a lot harder. There's a lot of more corner cases. So that's certainly navigation in this dynamic, unstructured environments, certainly a very, very challenging problem. And I guess, maybe the third one certainly is also a problem, is obstacle detection. So you normally think of that as, I'm just going to put a 3D camera and problem solved. But the problem is there's these really complex obstacles in the real world. Things like cables or a rug or a newspaper folded sideways kind of thing. So it's very difficult for any sensors to pick that up. And so I think, again, those 3 problems I described, I think Avidbots has been working on them for many years, but we still have ways to go to get it to perfection for sure.
Yeah, I'd like to touch again. You mentioned this is a really good point, but I would like to touch about the changing environment. You mentioned airports, for example, and warehouses. Maybe it's fixed, but if you speak about airport changing decoration, it's changing. How you manage this intelligence to, yes, let's say this part with this a changing environment, because it's tricky or challenging, as you mentioned. How you deal with that? If you can, yeah, give a overall picture about this challenge. Yeah.
Yeah, for sure. So yeah, localization is, I would say, an area that we have researched for a long time at Avidbots. There are some open source even tools out there that try to solve it, but so I guess we basically, and again, we've iterated for many years. We have many different approaches. Um, in a nutshell, I guess basically we're building like a local submap and then trying to align it with a bigger map, and that's in essence how it sort of works. But and again, and is able to then, if that area, that temporal area has changed a lot, if you can still align it with how the building used to look like in a bigger picture, then you're able to repair the map in that specific area. So it's certainly a challenging problem, and I wouldn't say also it's completely solved either. Like we do have locations where it's changed like more than 80%. Like it's just really really different, and then yeah, then we cannot really localize in that case, which is we use a lidar, basically two-dimensional lidar. So then it becomes just too difficult. But again, it's something that we're exploring. We're looking at other sensors. We're looking at other things. I know some companies in the market are using 3D lidars, and they look at the ceiling. That's actually very exciting as well in our industry. A lot of the autonomous cars technology is making it into our industry. So I remember vividly, as a grad student, I had a 64-line Velodyne in my desk, and it was like 80K, and I was like so happy to be able to play with that data. But now you can buy literally a 32-lane, like 200-meter range lidar for like $2,000. So it's really exciting what's happening in the world, and they're using these 3D lidars to look at the ceiling. So like those outriggers, those metal structures in the ceiling, those are very static. They don't change. So those are good features to localize again. So we're exploring some of that. Yeah, it gets very tricky in some warehouses where it's completely different, or in some of these grocery stores where they just change everything. You really need some other way to localize.
Great. Maybe I want to touch again about the design of the robot itself, because when you see different design, I don't know which basis did you choose the design for the hardware, just body of the cleaning robot here. How you choose this design and which basis you choose the design of that robot.
Yeah, we that's a good question. We have a bit of a museum at Avidbots. We have like all this like 10 plus prototypes that we've been building. We started trying to like get a cleaning machine that was built for humans, and then modifying it to be a robot. We quickly found out that it's a bit suboptimal, because really when you design something to be used by a human, you have to make sure that the human has line of sight to the floor, ergonomics, or sometimes a lot of machines, the human sits on the machine and drives the machine. So there's a lot of volume and design for the human. So I think at Avidbots we do believe that the future is robots, that you don't necessarily are going to have like humans using the machines for much longer. So we did design it as a robot first. And so yeah, we're able to then put the 3D cameras in better places, the sensors in better places. We also are able to pack a lot of water, because we don't have the volume of the human or the volume of the line of sight. So our robot is very, very narrow. It's just over a meter long, but it can run for like 5 hours. So it is really the best in the industry when it comes to runtime and maneuverability in tight spaces for that reason. So yeah, I do. That's gonna be a big, I think a big thing in robotics, like to watch. Is there gonna be forklifts that are only robots? Is there gonna be, cars that are only robots? Is there gonna be, cleaning machines that are gonna be only robots, or mostly robots, and then manual? So you can still use them manually, but it's not the nicest experience. So that's really, I guess, a question of where the future is going. At Avidbots, we do believe that we're building products, and we're building products for use. So it is important that they are designed as robots first, and then manual machines second.
I don't know if in the beginning of the Avidbot, do you have moments just like failure happening or interesting, yeah, study that maybe you tried to implement someplace that was just we didn't expect that. Do you have this moment unexpected or in the design? Just let's change that. Was eye-opening to change the way of the thinking and the design and iteration. I don't know if you have those moments.
Yeah, for sure. Many times, a lot of battle scars for sure. Of course, you read all the books and product management and product discovery, and certainly a lot of them say some of these things, but I think it's hard to apply it a lot. Like I think you know like we will, for example, at the beginning we went and talk to a lot of cleaning people, and we're like interviewing them and trying to understand it. But it's very. I do think and again, this is written in some books, maybe not with as much stress as this probably should be, but is that really, as a product manager and product designer, you need to get into what you're trying to automate. You need to become kind of like an expert, and for example, at the beginning we asked people, we're like, what do you want in a cleaning robot? They're like, I wanted it to get really close to the wall. I wanted to get really, really close. So that's all we did. We just spent a lot of energy making a robot that got really, really close to the wall. But then when we took it to the field, the productivity was very low. And then the truth is actually that like 3 or 4, actually no more, probably like 5, 10 people we interviewed, they all believed something that was so important, but in reality actually wasn't important. What they really, really wanted actually was productivity and was the speed. And so I think I will say, like as a tip to anybody or in general, you have to really do it. So then what we started doing, I actually did it myself. I spent like 2 months cleaning overnight. Like I was actually there with the machine, and I will watch how they will clean. I will watch all their behaviors, all that they will do. And I started learning how to mop, how to like do all of these things, because that I think that's truly the only way, by truly immersing yourself into what you're trying to automate and truly understanding how it all goes together. That's when you're like, okay, so that's what the robot needs to do, and then you're like, okay, then for yourself as a customer, what would it be great if the robot did, right? So then really to us, one of the big also differentiators of Avidbots is we have 24/7 support. So our robot, if you press play, you can walk away, the robot will do the rest. If it gets stuck for whatever reason somewhere, we have a team that can jump in and unstuck the robot remotely in our command center. So it really, again, as the human, you pressed go and you walked away. So again, you only get these insights through a very deep understanding of the activity. And again, and this happens all the time, and we've even done other products where it has happened again, and it's just a tough thing. It's one of those things that I think is certainly written in books and things, but once you apply it, I think it's something that is easy to forget and is very important.
Right, that's a good point. Maybe I want to ask you what maybe certain task still very challenging for the cleaning robot developer that Avidbot that, or maybe in general, do you think it's very challenging to do compared to human do this cleaning? Do you think there's certain tasks still very challenging and complex to achieve in cleaning?
I mean, I think, well, so cleaning itself is just the scrubbing part is something that we can solve, and we've been working really hard, so it's okay. I think the big one is really just that navigation, right? That navigation in unstructured environments. A big one that still is a problem at Avidbots, that still I think is a problem in the industry overall, is really sensing. We can detect obstacles that are 15 centimeters or more, but can we detect, a phone in the floor or a cable in the floor, or complex things that maybe are obstacles, but you don't think that there should be, like maybe like a little pool of water or something like that maybe you don't want to pick up, maybe you do want to pick up. So there's a lot of this human contextual understanding, right? Humans are just really smart. They can see things. There's also saran wrap, for example. Those things get clogged in cleaning systems all the time, and then they get trapped in the bearings and then they damage them. So there's a lot of that. There's a lot of this. And so actually we're excited, and I think the industry is probably going that direction as well, looking at things like deep learning to solve that problem. So similar to what cars are doing. So where you you will do segmentation of the environment, and you'll detect that this is not an obstacle. This is an obstacle. Those are things that I think it's but you see, I would say all these problems are fundamental robotics problems for navigation in dynamic unstructured environments. Again, especially for spaces like the ones we work on, is we are in the real world. We're in like a grocery store, we're in a mall, we're in a train station. I think maybe those issues aren't as pronounced in warehousing. So the AMR industry is very big in warehousing, but the moment you start going out, you start seeing all these other issues, all of these other corner cases, and so it's I think that's one of the definitely things we still have to improve, and it's a very exciting kind of a direction and new technology that we're able to leverage.
Maybe I'll ask you again from the customer perspective, because the designing of the robot, I don't know, do you consider also normal houses? Do you think, I don't know, how they think about the customers and their expectation? You mentioned they want certain things, but generally speaking, how do you see the customers that you expect to use Avidbot? Do you think you have to change something and each time you deliver the robot, for example, or it's a generic for any place to be deployed?
That's a good question. We do try our hardest to make it as easy to use as possible and as easy to deploy as possible. So we do send a technician to map the facility and to create what we call a cleaning plan. Again, to tailor it to your needs. We do try, I would say, our best to not really change the way they clean today, but rather kind of adapt. But frankly, in real life, I would say most of the times it does end up changing. Because the robot now can do it by itself, so then they sometimes relocate the labor to do more intense tasks, things like detail cleaning, things like window cleaning, that kind of thing. So I do think we end up changing the way they structure their setup, and that's the other thing too. I mean, it's cleaning teams around the world. Like, this is a true pretty much everywhere we interview. They never have time to do everything they want to do. They always want to clean more. They have all these tasks to do. And so, generally our robot, when it is sold, it doesn't actually replace people. It's more like they get to do other things because they always had more to do. And now the robot just automates this small task that used to be the scrubbing. So it's received very well most of the times. But I think that's the main difference with our competitors. Is we install it, then we have a customer success as well to make sure that the robot is doing well. And again, we have 24/7 support, so the robot never really gets stuck. When there's any problem, we jump in, and so there's a, the productivity is high and customers are happy.
So, I have a few questions for you, maybe about the failure and reliability, that you make sure you're cleaning the parts exactly. You mentioned limitation to sensor in general, and I understand this point, but if we speak about the mission of the robot, how we ensure it is reliable and accurate, and if there's failure, how they can adapt to this failure, whatever, and the robot's happening.
That's a good point. Reliability is a really important thing. I think it's something that, you see in robotics is not paid a lot of close attention to. I would say reliability, safety is also really, really important and rarely spoken in a lot of, kind of like academia and those kind of places. So reliability. Why is reliability important? I can show you some math that we did some with our customers. Like, if the robot is because now we're automating a task, right? So before you had a scrubber, and if the scrubber failed, okay, you just did it with a mop and whatever. But now you don't actually have a human to even go do that activity. So you have to bring somebody extra with a manual machine. So the cost is really, really high. There's some places in like Australia where the labor costs are very high overnight. So it's quite a bit. The difference between 70% reliability and 85% reliability is like hundreds of thousands of dollars a year. So it's really, really important. So that's a great point. We've put a lot of attention at Avidbots to really get to a very reliable system, both from autonomy as well as the machine itself. Safety I think is also really important. One thing maybe that it's not very famous, and if I may say, it is very exciting as well. Again, I do feel like a lot of the things we're doing is like the first to the industry. It is actually true. I was part of the founding members of IEC 63327 is a standard that just got published a couple months ago in May. It is basically probably the first safety standard at the IEC level, at the International Electromechanical Committee level, as the international level, about a robot in a mall, right? Like operating free in a mall. And so I do, it's quite exciting to be part of that. And it's, again, it's one of those things that I do think in the future is going to become a important thing that customers are going to realize that it's important to have. So it's certainly a key step in putting robots out there, for sure.
Mm-hmm. That's a good point. Maybe I'll ask you what changed in your way of thinking since you started at the beginning at different problem and it changed it and was eye-opening to consider other problem. But now what changed in your mind every step that you go and the company grow and you have more clients here? I mean, it's changing. What actually changing in the way of thinking and technology? How it's changing mind?
Yeah, it's a good question. So yeah, I think at the beginning of development is really fun. Early days of any startup, right? From an engineering point of view and a product point of view, is really fun because you're just solving a problem and it's very open-ended, and you also don't have a lot of customer problems. I think that's certainly a fact, and so I think it's easy to develop a lot of features quickly. Your speed is very fast. You get a lot of things done. You get a lot of features out there. So when you're early on, that's kind of the spirit and the feel of it. But yeah, as you start scaling, we have already in the several hundred robots deployed out there, north of 700. So it now becomes a question of more about scalability and reliability and code quality and really a startup transforms from a kind of a early development and creating new features and expanding the verticals to more of like now we have to really make it stable. We now have to think about code quality, code coverage, continuous integration, infrastructure, and standards around all that, and then building an organization really. Now you're building an engineering team that is capable of producing stable software and features. So that's a very different thing. I do think sometimes, even if you look at our engineering organization, basically we do have about 25 or so out of the 75 developers, only 25 of them are autonomy. So there is a lot around enabling this. It's really about the organization and a stable system and quality and just proper engineering development. That's quite key for companies to scale and for the product to be reliable, to be time and time again, because it's used every single night for 4 hours. So it really has to deliver that. So, and certainly in the hardware development as well, how do you do reliability? How do you do component failure analysis? How do you ensure that it's going to work for a long time? So that I do think the mindset has changed a little bit from more of a, that kind of style. But it's certainly we also try and keep alive the kind of the innovation side and things. So we have a small advanced technology group that is continuously trying new technologies and trying to be like the early Avidbots where they just developed things. So.
Yeah, that's a good one. Maybe a quick question here about to be innovative and creative and maybe doing risky ideas here. How do you see the competition since you have now the customer and the market and sometimes I don't know, but you have now the expertise when you introduce new stuff, maybe you don't know how it's go. It has two possibilities here. Maybe I'm wrong, but I'm curious from your point, the competition and have the customers and delivering new ideas or features maybe. How do you see all this mesh together to get something successful and the customer appreciate it?
Yeah, no, I think we of course you first have to start with the customer. You have to start with the problem. You have to I still think there's we have quite a few years to go to get it to this perfect world, right? Where you just drop this robot in a grocery store and it just cleans everything. And there's still issues. There's still things to improve, and so we have to start from the customer. The competition, it is tricky. Our space. It's as you know, we're cleaning machines are probably number 2 in terms of the largest application of AMRs in the world. Logistics and warehouse is certainly number 1. but cleaning is number 2. So there is now a lot of competition as well. So it does get interesting. I still think we as a company have, again, we do put the customer first, we do put that experience first, and we want them to just have a great experience and just press the go button and walk away. That is really our promise, and a lot of the technology development is based of that promise. So yeah, we are definitely innovating in some of those areas. I guess you did ask also about like releasing, and that's actually an interesting thing we do at Avidbots that maybe is of value to others. When we release new algorithms that are something that maybe works in like a small location, what we do is we call this alpha beta releases. So we first release to a group of about 10, 20 customers, and that's called an alpha test. And then once that's working successfully, deploy to a bigger group. It's kind of like A/B testing in websites, but it's different in automation and robotics. Like algorithms are, you only the corner cases will only appear once you really deployed it, right? Once you really put it in the real world and you really run it. And so it's really interesting to watch these algorithms do very well in the small groups, but then as you do the different installations, things start to break. So we've developed this alpha of 20 customers, then a beta with 30 something customers, and then we release. So it does take time. It does slow down a bit the innovation, but it is then a way to do it in a reliable way and with precision, and to ensure that the customer has no problem with experience. So that has definitely worked for us, and I will say something that probably robotics people should keep in mind, that algorithms are just difficult, right? Like we just don't know. The real world is the real world. No, nothing survives that contact, right? So I think it's important to be aware of that and to plan with that in mind.
Great. Maybe I want to ask you about the potential customers. I really you mentioned a few of them, but I mean, from university, do you think there is a cooperation like research and development? What are other potential customers you expect? The potential customers for Avidbots here.
So yeah, we are planning to expand our portfolio. Like we have one robot today, but we're planning to expand our portfolio. The other exciting thing with Avidbots, as you know, we have this idea of add-ons. It's an idea that we're really excited about, that we do think is the future of AMRs in the real world. So we basically are able to attach a disinfection module to Neo. So Neo is a cleaning robot, but then you attach a tank and then an electrostatic spraying gun, and now it's become a disinfection robot. And so it's really, really powerful. It's a really good way to have a stronger ROI for your robot, because in the future, I imagine robots having 5, 6 applications, kind of like computers were in the 80s and phones were in the 2000s, where you really multiply the value of the investment because you just have all these other applications. Like I do expect robots doing delivery or doing advertising, doing disinfection, and doing cleaning. So cleaning is the first function, but it's got like 3 or 4 more functions. So I think that's really going to open up the kind of the customer base, because again, people who I do expect that in the future, when you want to buy a delivery robot for your hotel or for your university or whatever, you will think twice. You will be like, oh, but if I bought this one, then I can have 5 applications. And and the power there too is the cost, right? You're able to deliver those extra applications for a few $100s a month. So the ROI becomes really, really powerful. So anyway, so that's I think customer-wise, robots, yes, our customers are cleaning operators right now, but I'm curious of how that will change as we do add-ons and as we have more add-ons, about how maybe there's different departments within a facility that have something to say there. You also asked about the universities. We do have some collaborations. Again, my alma mater is University of Waterloo. We have great relationships there. Some really, really good professors that are helping us. We are also looking to join in Canada, there's some robotics networks, the Insert Robotics Network, something we're looking at joining. We're joining Vector Institute. So yeah, we're trying to connect more with universities. Certainly, yeah, universities are a great way to do that research, to do those really hard problems and again, there's people there, they're just brilliant researchers that we can both each other's leverage each other. We give you a hard problem, we give you data. You will otherwise not have the data, right? Like you need, industry to give you the data and the problems, and yeah. Again, I think we run into this fundamental robotics problems all the time, and I think it's a very good thing to research in those things. It's easy to say it's kind of solved. It's easy to get a problem to 60, 70%. To get it to the 80, 90 is tough. And it's something that, yeah, we're happy that some researchers in some institutions like it and we work with them. So, yeah.
I don't know if you have any final words like to say here. Any final words like to say?
I would just say, it's a tremendously exciting time in the AMR world. I do everything. All the arrows are pointing for like us being at that inflection point of growth in AMRs, and it's just super exciting to be part of it. And I do encourage anybody who's studying or at the beginnings or considering a career move. AMRs are going to, yeah, they're gonna blow up very soon. In the next 5 to 10 years is gonna look very different. Cleaning market is gonna be 30% automated by 2025, 2026. I think a lot of other things are gonna get automated as well. So it's a wonderful time. It's really exciting, and I will encourage people to join it because it's really fun to ride that wave of growth, and yeah, hopefully we get to put robots out there and helping humans. So it's a good time.
Thanks so much, Pablo. It was such a pleasure talking to you and really, really inspiring listening to you. Thank you. Thank you so much.
Thank you. Appreciate the opportunity. Thank you very much.